Imagine opening your eyes inside a silent observation chamber, far beyond Earth, far beyond clouds, oceans, cities, weather, and the blue shelter of the sky. Outside the glass, there is no wind pressing against the window, no sound moving through the dark, no horizon dividing above from below. There is only blackness deeper than night, and a scattering of stars so sharp they seem almost carved into the void. For the first few seconds, you might wait for the universe to begin performing. Somewhere in memory space is full of color, purple nebulae, glowing rivers of dust, galaxies turning slowly in the distance, stars rushing past like sparks from a fire. But nothing rushes, nothing roars, nothing blooms suddenly into cinematic light. The real universe does not arrive like a movie screen. Instead, deep space asks you to become still. The longer you look, the stranger the scene becomes. The stars do not twinkle because there is no restless atmosphere bending their light. The darkness does not soften because there is no air to scatter sunlight into blue. Distance loses its familiar meaning because there is no road, no mountain, no foreground, no object nearby enough to help your brain measure scale. And yet, this emptiness is not truly empty. Your eyes are only narrow instruments tuned to one small band of reality. Around you, invisible light, charged particles, ancient radiation, and the hidden structure of space are present without appearing as color or shape. The universe is not dark because it has nothing to show. It is dark because most of what exists is not made for human sight. So, for 1 hour, we will stay inside that quiet chamber and look outward. What would deep space actually look like if we stripped away Earth's atmosphere, cinematic imagination, and telescope-enhanced color? And what would we slowly understand about the universe when we realize that seeing less might be the beginning of knowing more? The first thing you lose is not gravity or sound or even the feeling of Earth beneath you. The first thing you lose is the sky. Imagine the chamber becoming still around you. The glass is clear. The lights inside have been dimmed until they are almost gone. You are safe, breathing normally held inside a small human pocket of warmth and pressure. But outside, beyond the thin boundary that keeps your body alive, there is no air, no blue, no weather, no horizon, no familiar ceiling of atmosphere above the world. At first, your mind may try to build a sky anyway. It may search for something soft between you and the stars, some faint veil, some dim blue-black dome, some suggestion of distance layered gently over the dark. That is what a lifetime on Earth has taught you to expect. Even at night, Earth does not give you pure space. It gives you atmosphere. It gives you moisture, dust, turbulence, scattering city glow, air glow, and the faint visual texture of a planet wrapped in gas. But here the wrapping is gone. There is no blue sky because there is nothing around you to scatter sunlight into blue. There is no soft brightening near the horizon because there is no horizon at all. There are no clouds catching light, no high cirrus streaks, no pale dawn hidden somewhere below the curve of the world. There is not even the feeling that above and below are meaningful words. Outside, the window direction itself begins to loosen. For the first minute, that may be more disturbing than beautiful. The human eye is used to seeing through something. On Earth, even when we think we are looking at the sky, we are looking through air. The atmosphere bends light, scatters, it dims, it colors it, and makes distance feel alive. The blue of the daytime sky is not the color of space. It is the color of sunlight being broken and scattered through gases above us. Deep space removes that familiar translation. What remains is blackness so direct that it feels almost unnatural. Not a dark room, not a cloudy midnight, not the black between trees in a forest. Earthly darkness usually has texture. It has nearby surfaces, hidden shapes, air, sound, smell, and the quiet sense that the world continues around you, even when you cannot see it clearly. This darkness has no texture in the ordinary way. It does not gather in corners. It does not soften along a roofline. It does not deepen under a hill or fade toward a street lamp. It is simply there, everywhere the light is not. It has no atmosphere to make it gradual. It has no foreground to hold your attention. It is not a place your eyes can enter step by step. It is the absence of the sky you were born under. Because the sky is so ordinary on Earth, losing it feels almost like losing a sense. We rarely think of the atmosphere as part of vision. We think of it as air, weather, breath, climate, something around the body. But it is also part of how the eye understands the world. It gives the sun a halo. It makes distance fade. It turns mountains blue at the edge of sight. It lets clouds reveal height, movement, wind, and time. Without it, space does not look higher. It looks exposed. You may expect the stars to flood in immediately, as if the disappearance of the sky should uncover a grander ceiling behind it. But in the first seconds, the shock of blackness may come before the stars. The eye is still adjusting. The mind is still searching for a frame. The scene has no scale, yet no floor, no far wall, no edge where darkness becomes something else. There is only the chamber, the window, and an outside that refuses to behave like a landscape. On Earth, the horizon is one of the great quiet comforts of vision. Even when we do not notice it, it gives the world an arrangement. The ground ends there. The sky begins there. Clouds move across that space. Birds cross it. Mountains rise into it. The sun sinks toward it. The horizon lets the brain build a map before thought even begins. In deep space, there is no such line. If the chamber is far from any planet, moon, or large nearby object, nothing divides the view into upper and lower halves. Nothing tells you where the world rests. You can turn your head, and the darkness continues. You can imagine yourself upside down, but the phrase no longer means much. Upside down compared with what? There is no ground below the window, no sky above it, no distant sea level of the universe. The body may still remember orientation, but the view does not confirm it. This is one of the first quiet ways deep space begins to break human intuition. We do not only see with our eyes, we see with expectations built from gravity, ground air, and light. A child learns that things fall downward, that the sky is overhead, that far objects sit behind, near ones that clouds move through air, that sound often comes from what we see. Deep space removes these agreements one by one. Even silence becomes part of the visual experience. Strictly speaking, silence is not something you see. But inside this chamber, looking outward, you would feel the absence of sound changing the scene. No wind rubs against the glass from outside. No distant thunder carries through vacuum. No roar comes from stars. No engine of the cosmos hums across the dark. If anything is heard, it belongs to the chamber itself. Air circulation, your own breathing, perhaps a soft mechanical vibration through the structure around you. Outside the universe gives no soundtrack. That absence matters because modern imagination rarely lets space stay silent. Films fill it with rushing ships, explosions, deep bass notes, and dramatic tremors. They make the vacuum behave like an ocean or a storm. They give motion, a sound danger, a sound scale, a sound. But real deep space offers no air to carry pressure waves from one place to another. The darkness does not announce itself. It waits without voice. In the first minute, this silence would make the blackness feel larger. On Earth, sound helps us measure space. A room has a tone. A valley has an echo. A forest has layers. A city at night murmurs with distance. Even the sea tells you how wide it is by the way its sound arrives. In deep space outside the chamber, that acoustic depth is gone. The eye is left almost alone, and the eye is not ready yet. Human vision takes time to adapt to darkness. In the first minute, the pupil can widen, but the deeper transformation of night vision has only begun. The rods in the retina, the cells most useful in low light, need time to become more sensitive. At first, your view may feel almost too empty, not because nothing is there, but because your eyes are still moving from a life of brightness into a place where light arrives in thin, ancient threads. This gives the first minute a strange delay. You are already in space, but you have not yet learned how to look at it. The universe is present, but your body is still catching up. The mind wants immediate revelation. It wants the window to become a screen, the blackness to become a painted image, the stars to arrange themselves into spectacle. But the real view begins more slowly, almost reluctantly. You do not enter deep space all at once. Your senses enter it by degrees. At the edge of the window, a few points of light begin to sharpen. They do not bloom through haze. They do not tremble like candles in moving air. They are small, cold, steady, and almost severe. Around them, the blackness remains complete. There is no glowing sky between them, no blue wash, no atmospheric veil, no gentle gradient to persuade you that space is a dome. The stars appear not as decorations on a sky, but as separate punctures of light in an enormous dark field. That difference is subtle but important. From Earth, stars belong to the night sky. They seem attached to it, scattered across it, framed by trees, rooftops, mountains, deserts, oceans, or city edges. They are part of a scene that still feels planetary. In deep space with the atmosphere gone, the stars no longer sit inside a sky. They appear beyond the very idea of sky. You are not under them. You are among lines of sight reaching toward them. The sky has disappeared because the sky was never the universe. It was Earth's local way of showing you the universe. The blue sky, the twilight sky, the starry sky, even the storm sky all belong to a planet with atmosphere. To lose that filter is to discover how much of your sense of beauty has been shaped by shelter. The chamber becomes a kind of border between two kinds of existence. Inside, there is pressure, warmth, breath, and the soft familiarity of human survival. Outside, there is vacuum radiation distance and a darkness that does not care whether it is understood. The glass makes the view possible, but it also reminds you that your body does not belong out there unaided. You are seeing the universe from inside an artificial atmosphere, a tiny portable version of Earth. This matters because vision is never separate from the body that sees. A camera can record photons without fear. A telescope can gather light for hours. A sensor can register wavelengths no eye can feel. But you are not a sensor. You are a living creature whose eyes evolved under sunlight and atmosphere, whose brain expects ground and horizon, whose nerves listen for sound, whose balance system expects gravity to organize space. Deep space is not only visually unfamiliar, it is biologically unfamiliar. The first minute reveals that mismatch. It does not do so loudly. There is no sudden event, no object rushing toward the chamber, no cosmic drama. Instead, the mismatch arrives through subtraction. Remove the sky, remove the horizon, remove sound, remove the ordinary clues of distance. What remains is not nothing, but it is less human than any landscape you have ever known. That may be why the first minute in deep space would feel both empty and overwhelming. Empty, because there are no clouds, no nearby mountains, no weather, no moving branches, no colored air. Overwhelming, because there is nothing to protect the mind from the scale implied by the dark. On Earth, the sky covers space with familiarity. In deep space, the cover is gone. The universe is not showing more yet. It is removing the language by which you expect it to see. After a while, your breathing inside the chamber may become the most intimate thing in the scene. A faint inhale, a faint exhale, the smallest possible weather held within your own body. Outside there is no wind. Inside, the lungs continue their quiet tide. The contrast is almost tender, a human rhythm beside a darkness that has no rhythm the ear can hear. Then the first minute begins to lengthen into the next. Your eyes continue adjusting. The stars become more certain. Their points grow steadier, clearer, and more numerous as your vision settles. The blackness remains, but it is no longer a blank. It is beginning to hold structure, though not the structure films promised. Not glowing clouds, not rushing lights, not color pouring across the window. Something colder, something sharper. And this is where the next surprise begins. Because once the sky has disappeared, once the atmosphere has been removed from sight, the stars themselves stop behaving like the stars you remember from Earth. They do not flicker. They do not shimmer. They do not seem to breathe in the air. They wait steady and distant in a darkness without wind. After the sky disappears, the stars begin to change. At first, you may not notice the difference clearly. Your mind still carries the memory of night on Earth, where stars seem to tremble slightly, as if they are alive in the cold air. From a field, a mountain road, a desert, or the deck of a ship, starlight rarely feels completely still. It flickers, it wavers, it pulses faintly above the horizon, especially when the air is restless. But here outside the chamber there is no restless air. There is no atmosphere between your eye and the light, no rising heat from the ground, no high-altitude winds sliding across invisible layers, no shifting pockets of warmer and colder gas bending the beam on its way down. The light reaches the window without passing through the turbulent ocean of air that normally waits above Earth. So the stars do not twinkle, they hold. That steadiness may be the second quiet shock of deep space. Not the absence of the sky this time, but the absence of the little movement you expected from stars themselves. On Earth, twinkling makes stars feel delicate and near like candle flames shivering in the distance. It gives the night a kind of breathing texture. It makes the heavens seem alive in a familiar, almost intimate way. In deep space, that breathing stops. The stars become sharper, smaller, and more severe. They do not flutter. They do not smear through air. They do not appear to swim in the atmosphere. They are points of light set into blackness with an almost mathematical patience. Some are bright enough to catch your attention immediately. Others sit faintly at the edge of awareness, waiting for your eyes to adapt more fully before they begin to appear. This is not less beautiful. It is only less Earth-like. The twinkle you remember was never truly the star. It was the journey of the star's light through Earth's atmosphere. The star itself may be enormous hot and violently active, its surface boiling with magnetic storms, plasma, and radiation. But from the ground, after its light has crossed the vastness of space and then passed through the last few miles of air above us, what we see is a softened, trembling point. Earth adds the trembling. Deep space takes it away. Because deep space takes it away, the stars may begin to feel more distant, not less. They are no longer little sparks playing in a sky. They are steady evidence of impossible separation. Each point is a sun, or in some cases, a system of suns so far away that even light needed years, decades, centuries, or longer to reach the place where you are watching. A flickering star can feel like a companion. A steady star can feel like a fact. From the chamber, the familiar romance of the night sky gives way to something cleaner and colder. The stars are no longer softened by the last layer of Earth. They are not filtered through the living air of a planet. They arrive as direct points of visible light from bodies that may be larger, hotter, older, and more violent than the eye can show. For a while, you may simply look at them. The chamber is quiet. The dark remains without texture. Your eyes settle. More points begin to appear, though not in the way a long-exposure camera would reveal them. The human eye is sensitive, but it is not endlessly patient like a telescope sensor. It cannot gather light for minutes or hours and stack the faint photons into a rich image. It receives what it can receive in the living moment, so the view remains restrained. There are more stars than you would see from a bright city, perhaps more than you have ever seen from the ground, if your chamber is far from sunlight and glare. But the universe does not suddenly become crowded with suns in every direction. You are still limited by the aperture of the eye, by the sensitivity of the retina, by the brightness of individual stars, and by the fact that most stars in the galaxy are simply too faint or too distant to be seen without instruments. Deep space removes the atmosphere, but it does not make the eye into a telescope. It gives you a clearer view, not an unlimited one. That distinction matters throughout this journey. To leave Earth is not to become all-seeing. It is only to remove one filter. Another filter remains inside you. Your eye is a biological instrument, not a cosmic one. It evolved to detect sunlight reflected from leaves, skin water, stone, fire, predators, fruit paths, faces, and motion across distances useful to survival. It was not built to collect faint galactic light across hours. It was not built to separate every star in a distant cluster. It was not built to resolve the disks of stars scattered across light years. That is why most stars remain points. Even the largest stars are so far away that their apparent size is far below what the unaided eye can resolve. They are not small in reality. Some are far larger than the sun, brighter than the sun, more violent than the sun. But distance compresses them into almost nothing. A star may be a colossal sphere of plasma. Yet to you, it arrives as a single bright prick of light with no visible surface, no visible storms, no visible edge. A star can be immense and still appear almost dimensionless. The window gives no disk, no burning edge, no visible boiling surface. It gives a point. That point may have planets around it, magnetic storms crossing it, flares rising from it, and layers of plasma moving under forces too large for ordinary imagination. Yet none of that enters the human eye from this distance. The simplicity is beautiful, but it is not complete. Some stars would show subtle color. A bright blue-white star might feel colder and sharper. A red or orange giant might carry a faint warmth if it is bright enough for your cones to respond. But many stars, especially fainter ones, would appear mostly white or pale because dim light does not easily awaken strong color perception. Deep space is not colorless in itself. Stars have temperatures. Nebula emit and reflect light. Dust absorbs and reddens starlight. Galaxies contain star-forming regions, old yellow populations, blue clusters, and glowing gas. But the naked eye receives only part of that richness. The star field outside the chamber may therefore feel almost austere, black, white, a few hints of blue, gold, orange, or red, points rather than disks, steadiness rather than flicker, vastness without visible depth, beauty without softness. From Earth, even the darkest mountain sky is still connected to the body. You stand on ground. You feel temperature. Air touches your skin. Trees may edge the view. The stars rise and set because Earth turns beneath them. They belong to time. You can point to the east, the west, the place where morning will come. In deep space, there may be no dawn, not in the ordinary sense. If you are far from planets and not oriented near a nearby sun, the stars do not promise morning. They do not gather toward a horizon. They do not cross a sky above a sleeping landscape. They simply remain surrounding a chamber that carries its own little pocket of human time. The clocks inside may say that minutes are passing, but the view gives almost nothing away. This can make the stars feel older than time, though of course they are not timeless. They are born, burn, change, and die. Some are young and hot. Some are ancient and dim. Some may already have changed since the light now reaching you began its journey. A star you see as present is always, in a sense, a star from the past. Every point is delayed. You never see a star exactly as it is now, if now means the same moment in your chamber. You see light that has traveled. The nearest stars are seen as they were years ago. More distant stars are seen as they were decades, centuries, or millennia ago. The farther the source, the older the message. The night is full of arrivals. In the first hour of observation, you would not feel this delay physically. Nothing about the light tells your eye how long it traveled, but the knowledge changes the mood of the view. The steady points outside are not just objects in space. They are moments from different times entering your present together. The brain wants a picture to be simultaneous. It wants the view outside the window to be happening all at once. But in deep space, as on Earth, astronomy is always a form of looking backward. The stars without TWINKLE are not simply far away. They are temporally distant. They bring old information arriving quietly without sound or explanation. Perhaps this is why the stars in deep space might feel less romantic at first, then more profound later. On Earth, their twinkling gives them personality. In deep space, their steadiness gives them distance. What they lose in charm, they gain in severity. They no longer seem to be little lights trembling above a sleeping world. They become suns separated by darkness so wide that light itself must spend years crossing it. A few bright points may become familiar during the hour. You may return to them with your eyes as if they were landmarks. One blue-white star near the edge of the window. One golden point, slightly brighter than the rest. One faint cluster that appears more clearly when you look beside it. Your brain, always trying to make a world, begins to settle into the pattern. It starts to turn the unimaginable into a room with reference points. That is what minds do. They build shelter from repetition. But deep space resists complete shelter. The more you look, the more the stars reveal the limits of your looking. They show you light, but not distance. Brightness, but not size. Color, but only faintly. Pattern, but not physical connection. Presence, but from different times. Steadiness, but not stillness in reality. For 1 hour, your eyes can only begin to receive that. They cannot measure it all. They cannot open every wavelength. They cannot resolve every surface or separate every distance. But they can show you that the universe is not the sky. The stars are not decorations on darkness. They are not trembling lights above Earth. They are real suns, steady, because the air is gone distant, because space is large, faint, because the eye is small, and as the hour continues, the steadiness begins to create a new kind of expectation. If the stars do not twinkle, perhaps they will move. Surely, somewhere in this enormous darkness, something should drift past rotate approach or slide across the window. The films of your memory still expect speed. Ships rush, stars streak, galaxies turn. Space seems like a place where everything is always crossing the frame. But the stars remain, the window remains, the darkness remains, and slowly the next surprise begins to form. The universe is full of motion, but almost none of it is offered to the human eye in the scale of a single hour. After the stars become steady, another expectation begins to fail. You wait for motion. Somewhere in the back of the mind, there is an old cinematic memory of space. Stars stretch into lines. Bright points slide past the window. A spacecraft seems to move through the universe the way a car moves down a road at night, with lights approaching, passing, and fading behind. Space in that imagination has speed you can see. It has direction you can feel. It has the visual rush of travel. But deep space offers almost none of that. The stars remain in place. The blackness holds its shape. No glowing object crosses the window unless something very nearby happens to be moving relative to you. No river of light streams past the chamber. No background shifts the way trees shift outside a train. Even if your chamber is traveling at a speed that would seem enormous by human standards, the view may still appear nearly frozen. This is one of the strangest truths of space. The universe is not still. Everything around you is moving. Stars orbit through the galaxy. Planets circle stars. Moons circle planets. Galaxies rotate. Clusters of galaxies drift under gravity. The sun itself moves through the Milky Way, carrying Earth and the rest of the solar system with it. Nothing is fixed in an absolute sense. And yet, to the human eye, during one quiet hour, almost nothing seems to move. The reason is not mystery, but scale. Motion becomes visible when something changes position against a background you can compare it with. On Earth, motion is easy because the world is full of nearby things. A bird crosses the sky. A car moves past a tree. A cloud slides behind a rooftop. A person walks across a room. Even small motions are clear because the objects are close enough for the eye to notice their change in position. Deep space has almost no nearby scenery. There is no road beside you, no wall, no trees, no clouds, no mountains, no air filled with dust or moisture to make distance visible. The stars are so far away that even enormous movement barely changes their apparent positions over the span of an hour. They are not truly fixed, but they are so distant that their motion is hidden from the living moment. Physically, you may be moving very fast. If your chamber were near Earth, it might orbit the planet at thousands of kilometers per hour. If it were traveling with the solar system, it would share the sun's path around the center of the Milky Way at a far greater speed. If it were moving through interplanetary or interstellar space, it could still be crossing tremendous distances by human standards. But visually, speed without nearby reference points becomes almost meaningless. You do not feel cosmic speed the way you feel speed in a car, because a car gives you constant comparison. The road comes toward you, streetlights pass, trees slide backward, the engine vibrates, air pushes against the vehicle, the body reads acceleration, turning braking, and bumps. Movement is not just a number, it is a collection of signals. In deep space, those signals disappear. There may be no vibration from outside, no rushing air, no passing landscape, no ground under the wheels, because there are no wheels. If the chamber moves smoothly, at constant velocity, your body may feel no motion at all. This is not because you are not moving. It is because steady motion without acceleration and without reference points does not announce itself to your senses. The universe can carry you silently. This may feel almost impossible at first. Human intuition links speed with sensation. We expect fast things to feel fast. We expect distance crossed to create visual change. But space does not owe us that kind of feedback. The distances are too large, the visible landmarks too far away, and the human eye too limited in its ability to detect small angular changes across the sky. So the stars remain. For 1 hour, their positions may seem unchanged. A star near the edge of the window stays near the edge. A bright point above another bright point remains in its pattern. A faint cluster still sits where you first noticed it. If the chamber is not rotating, the scene can seem so still that time itself becomes harder to feel. You may begin to wonder whether anything is happening at all, but the stillness is not emptiness, it is scale. Imagine looking at a mountain from very far away. A person could walk along its slope, and from your distant viewpoint, the movement might be invisible. A river could cut through a valley, trees could bend in wind, animals could cross a ridge, and you might see only the mountain's quiet shape. Distance does not stop motion. It hides motion inside small angles. Deep space does this to almost everything. A star may be moving through the galaxy at tens or hundreds of kilometers per second, but from your chamber across 1 hour, it remains a point. Its true motion is spread across such vast distance that the change is too small for the unaided eye to catch. Astronomers can measure proper motion, the apparent shift of a star across the sky, over time, but usually over years, decades or longer, not through a casual glance over an hour. The universe moves on timescales that do not easily match the human body. This mismatch is part of what makes deep space feel so alien. Your heartbeat marks seconds. Your breathing marks minutes. A human day is built around the sun rising and setting. Human motion is measured by footsteps, roads travel fatigue arrival. But stars and galaxies live in measures so large that an hour becomes almost nothing to them. Inside the chamber, the hour matters to you. Outside, it is barely a blink. This does not mean nothing visible could change. If your chamber is near a planet-moon asteroid comet spacecraft or cloud of debris, motion could become obvious. A nearby object could drift across the window. A planet could show slow rotation. A spacecraft could pass. Dust or ice particles near the chamber could move through sunlight like tiny flecks. Motion returns whenever there is something close enough to serve as foreground. But true deep space removes most foreground. That is why the view feels still. Not because the universe is frozen, but because the visible objects are too far away to perform motion for you. Space does not behave like a tunnel filled with stars. It behaves more like an open silence where distance has swallowed change. This is also why science fiction often cheats, and perhaps has to. If a film showed deep space exactly as the eye would experience it during a smooth 1-hour drift, much of the frame might remain visually quiet. The ship would not seem to race unless another object was close. Stars would not streak unless the craft moved at extreme speeds far beyond ordinary spacecraft, or unless the image was deliberately stylized. The drama of motion would have to come from instruments' navigation and knowledge, not from the window. Reality is slower to the eye. That slowness can be disappointing if we wanted spectacle, but it can become profound if we let it teach us scale. The stillness outside the window is the visible consequence of distance too large for ordinary perception. It is not the stillness of a dead universe. It is the stillness of a universe whose movements are enormous, but whose stage is even more enormous. The body is used to a world where motion and meaning are close together. A rustle in grass may mean an animal. A shadow crossing the ground may mean a bird above. A wave lifting on the sea may mean wind or tide. On Earth, the eye is constantly rewarded for noticing movement. Motion often matters because nearby motion can affect survival. Human attention is drawn to it before thought. Deep space gives the eye almost nothing of that kind. No rustle, no passing shadow, no shifting cloud, no moving horizon. The stars do not help you survive. They do not signal weather. They do not reveal approaching animals or changing seasons in the immediate way Earth does. They are real, but they are not local. Their motion belongs to a scale where human urgency has no natural place. The mind may respond by becoming restless. If nothing moves, it may invent movement. It may feel that the chamber is drifting, even when the view does not confirm it. It may imagine that the stars are sliding slightly, or that the black field is turning, especially if your body lacks familiar orientation. In a place without ground, the boundary between actual motion and felt motion can become uncertain. The brain wants anchors. If the chamber slowly rotates, the stars would seem to drift across the window. That motion would be real in your view, but it would come from your frame, turning, not from stars sweeping around you. If the chamber stabilizes again, the stars would stop. In deep space, one of the few obvious ways to see motion may be to see your own motion reflected in the apparent movement of the star field. The stars become a mirror for orientation. On Earth, we often use the ground as the stable reference. The sky appears to rotate above us because Earth turns. In deep space with no ground and no horizon, the star field may become the nearest thing to stability. The dark field outside tells you whether your chamber is turning, whether your window is drifting across the fixed background, whether the little human enclosure around you is changing its attitude. The word motion sounds simple until space removes the obvious frame. Moving compared with what a person floating inside the chamber may feel motionless. The chamber may be moving relative to a nearby planet, relative to the sun, relative to the galactic center, relative to another spacecraft, relative to the cosmic background. There is no single stage on which everything moves. There are relationships. During the hour, the most visible changes may come not from the cosmos outside, but from the observer inside. Your eyes adapt. Your attention changes. Your sense of time slows. A star you barely noticed at first becomes familiar. A faint pattern becomes easier to recognize. The same view, almost unchanged, begins to feel different because the mind has spent time with it. When the universe does not visibly move, perception does. The scene outside may remain nearly fixed, but your relationship to it changes. The first minutes are filled with expectation. The middle of the hour may bring patience. Later, the stillness may begin to feel less empty and more immense, as if the lack of visible motion is itself a kind of information. You are learning that scale can hide movement. Think of the Milky Way itself. The galaxy rotates, but no human eye looking for 1 hour can see its stars revolve around the galactic center. Our sun takes hundreds of millions of years to complete a single orbit around that center. In the time it takes you to breathe, the galaxy has moved, but not in any way the window can reveal. Its motion belongs to a clock far larger than the body. The largest motions in the universe are often seen only by comparison measurement and memory. A photograph taken years apart can reveal what the eye cannot. Spectra can show motion through shifts in light. Careful measurements can uncover planets tugging on stars, stars orbiting unseen companions, galaxies, receding clusters, interacting, and distant objects changing slowly over time. Instruments build the kind of patience the naked eye does not have. Your hour in deep space is too brief to see most of that, but it is long enough to understand the problem. The problem is not that the universe lacks motion. The problem is that human seeing is local, short-lived, and hungry for nearby change. We evolved to notice what moves across a field, not what shifts by tiny fractions of a degree across a century. We are good at catching falling fruit, approaching animals, moving hands, waves, flames, and faces. We are not naturally equipped to watch galactic rotation. Deep space reveals this without explaining it at first. It simply stays still. There may be a moment, perhaps halfway through the hour, when that stillness stops feeling like waiting and begins to feel like scale entering the body. The stars remain fixed, not because they are close, but because they are far. The galaxy does not turn visibly, not because it is lifeless, but because its motion is vast. The absence of visual drama becomes a measure of distance. What seemed empty begins to become large. At that point, the window is no longer failing to entertain you. It is teaching you the wrongness of your expectations. It is showing that the universe does not need to move quickly across the eye in order to be moving. It does not need to rush past the chamber to prove that the chamber is traveling. It does not need visible change to contain constant change. This is a quieter form of awe. The chamber remains steady. Your breathing remains near. The stars hold their positions with a patience almost beyond feeling. Somewhere planets orbit. Somewhere a moon falls endlessly around its world. Somewhere a star drifts through the galaxy. Somewhere two galaxies slowly deform each other across millions of years. None of it hurries for you. And because nothing hurries, another question begins to rise. If motion is hidden by distance, then what else is hidden by it? If the eye cannot feel speed without a nearby reference point, can it really feel how far away anything is? The stars seem to rest on one black surface, but they do not. Some are closer, some are vastly farther, some are dim and near, others brilliant and remote. The stillness has led to a deeper uncertainty. You are not only unable to see the universe move, you are beginning to realize that you cannot truly see its depth. Once motion disappears, distance begins to collapse, not because the stars are near, not because the universe has become smaller, but because your eyes have almost no way to feel how deep the scene really is. Outside the chamber, the points of light seem scattered across a single black field, as if they were all fixed to the same invisible surface. Some are brighter, some are fainter, some seem slightly warmer or colder in color. But the eye cannot easily tell which ones are close, which ones are distant, which ones are ordinary, and which ones are enormous. This is the next quiet confusion of deep space. On Earth, distance is something the body understands almost without effort. You can stand in a room and know which wall is closer. You can look down a road and feel it narrowing away from you. You can see a tree in front of a hill, a cloud behind a mountain, a bird passing between you and the sun. The world gives you layers. It offers foreground, middle ground, and background. It lets your brain build depth from comparison. In deep space, almost all of those clues are gone. There is no road narrowing toward a vanishing point. No fog making far things pale. No mountain partly covering a farther mountain. No nearby branches moving against a distant sky. There may be only stars, each one so far away that its light arrives as a point, and the points do not tell you their true arrangement. They look flat, but they are not flat. This is one of the oldest traps in looking at the universe. The sky appears like a surface because the human eye receives directions, not distances. A star appears in one direction. Another star appears beside it. The mind draws a pattern between them because pattern is one of the ways we survive and remember. But the stars in that pattern may be separated by distances far greater than the distance from you to either one individually. A constellation is not a physical drawing in space. It is a projection. From Earth, ancient observers turned these projections into stories. They saw hunters, lions, scorpions, swans, twins, crowns, and rivers. The stories were beautiful, and for navigation calendars and memory, they were useful. But the stars making those shapes were not necessarily neighbors. They only looked related because they happened to fall along similar lines of sight from one small planet. In your chamber, the same illusion may remain, even far from Earth. As long as you are still near our region of the galaxy, many familiar star patterns would not immediately fall apart. The distances between stars are so large that moving from Earth to a spacecraft somewhere in the solar system would barely change the constellations to the naked eye. The sky map would not suddenly become three-dimensional. The old shapes would still cling to the view, not because they are physically real, but because the shift in viewpoint is tiny compared with stellar distances. That fact is humbling. You can leave Earth and still not move far enough for the universe to reveal its depth. A few million kilometers would be an astonishing journey by human standards. Even crossing the solar system would be a monumental achievement. But compared with the spaces between stars, such distances are small. The nearest stars are light years away. A light year is not a poetic phrase. It is the distance light travels in a year, and light moves faster than anything in the universe. When even light needs years to cross the gap, human travel becomes a small motion inside a very large room. So the star field remains almost unchanged. You may feel that you have gone somewhere unimaginable, and in human terms you have. You are no longer under the atmosphere. You are no longer inside the blue sky. You are looking into space without the softening filter of Earth. And yet the universe still refuses to give you obvious depth. It lets you travel far from home without visibly rearranging itself. The scale is too large to reward you quickly. This is why distance in astronomy often has to be built from evidence rather than felt directly. Astronomers use parallax brightness spectra, standard candles, redshift, and many other methods to measure what the eye cannot simply know. They do not look at a star and feel its distance the way a person feels the distance to a tree. They measure tiny shifts, compare physical properties, and build ladders of inference. The eye sees a point. Science asks what kind of point it is. A bright star outside the window may be bright because it is close, but it may also be bright because it is intrinsically luminous. A faint star may be faint because it is far away or because it is small and dim. Without additional information, brightness alone can deceive. The universe does not label its lights with distance. It only sends photons. Those photons arrive from different histories. One star may be a nearby red dwarf, small, cool, and faint, hidden from easy view despite its closeness. Another may be a distant blue giant, intensely luminous visible across a much greater span of space. To your eye, they may both be points. Their physical realities may be wildly different, yet the window compresses them into the same visual language. Point, point, point. The simplicity is misleading. Every point may represent a star with mass, age, temperature, magnetic activity, chemical composition, and perhaps planets moving around it. Some may be young, some may be near the end of their lives. Some may already have changed in ways you cannot know yet because the light now reaching you left long ago. Distance erases detail. It also erases danger scale and violence. A star can be a furnace of plasma, but from far away it appears gentle. A giant can throw radiation into space, but your eye receives only a quiet point. A supernova remnant can contain the remains of an explosion, yet without a telescope, it may be invisible. The universe is not calm because it looks calm. It looks calm because most of its events are too far away, too faint, or too slow to enter ordinary sight. The eye is not lying, but it is simplifying. It takes a universe of depth and returns a field of directions. It takes suns of different sizes and returns points of different brightness. It takes light from different years and gathers it into one present scene. It takes a three-dimensional galaxy and flattens it across the chamber window. You are looking into space, but you are not directly seeing space as depth. You are seeing the surface created by your own perception. If there were a nearby planet, moon, or asteroid, the situation would change. A large object close enough to show a disk would immediately give the eye something to measure. Its edge could move against the star field. Its shape could reveal rotation. Its brightness could change with phase. Craters, shadows, clouds, or surface marks could make it feel like an object rather than a point. But true deep space is often empty of nearby anchors. Without one, distance becomes conceptual. You know it is there, but you cannot feel it with the same certainty. The dark between stars has no visible walls. It does not fade with depth. It does not show a texture that becomes finer with distance. It simply remains black, and the stars rest within it, like clues separated from their scale. This blackness can make the universe feel strangely small at first. The stars may appear close together, arranged within a window only a few feet across. Your eye does not feel the light years between them. Your mind may understand the numbers, but the visual scene does not carry the numbers naturally. There is a gap between knowing and seeing. You may look at two stars, only a finger width apart, in the window, and know that they might be nowhere near each other in reality. One could be relatively close. The other could be far beyond it. Their apparent closeness is only a matter of angle. They share a direction from your viewpoint, not a neighborhood. This is why the universe is so difficult to draw honestly. A flat sky map can show where to look, but not the full depth of what is there. A constellation chart can guide the eye, but it cannot show how the stars are stacked across space. Even beautiful planetarium domes, useful as they are, reproduce the ancient illusion of lights on a sphere. They help us navigate the sky, but they do not fully break the sky open. Deep space breaks the idea of the sky, but not automatically the illusion of flatness. You have lost the atmosphere. You have lost the horizon. You have lost twinkling. You have lost the visible rush of motion. But the mind still turns the view into a surface, because that is the easiest way to hold it. Even in a spacecraft, even with knowledge of light years, the eye remains an earth-made instrument, searching for a readable scene. This can make the hour feel dreamlike. The stars seem near enough to a range too far to reach and too flat to measure. The blackness seems empty, yet it contains distances so large that ordinary words begin to feel weak. Near and far, bright and dim, small and large, old, and present all begin to slide out of their usual relationships. A bright point may be a distant giant. A faint point may be one of your closer neighbors. The view does not correct you unless you bring science to it. This is where astronomy becomes an extension of humility. It teaches that appearances are not useless, but incomplete. The eye sees something real, but not enough. It gives the first contact, the first wonder, the first pattern. Then measurement must enter, not to destroy the beauty, but to deepen it. Parallax is one of the simplest examples. When Earth moves around the Sun nearby, stars appear to shift very slightly against more distant background stars. The shift is tiny because even the nearest stars are extremely far away. But by measuring that tiny change, astronomers can calculate distance. It is like holding up a finger in front of your face and looking at it first with one eye, then the other. Nearby things shift more than distant things. The same principle works across space, but on a scale so vast that the angles are almost unbelievably small. Your eyes alone could not casually do this in 1 hour. The baseline is too small. The shifts are too tiny. The time is too short. To turn the star field into a depth map, you need instruments, repeated observations, and careful calculation. The direct view remains beautiful, but it remains visually compressed. This is why light years are so hard to feel. We can say that a star is 4 light years away, 10 light years away, hundreds of light years away, but the words do not create a natural picture. A year is already a human measure of time. To turn it into distance asks the mind to follow light through every second of that year, across every hour, every day, every month, without slowing. And yet outside the window, that distance may be represented by a point, a single point. This is perhaps one of the quietest forms of cosmic awe. The vastness does not always appear vast. Sometimes it appears small because the eye cannot unfold it. A star whose light has traveled for decades may occupy no more visual space than a grain of brightness. The distance is not in the image. It is in what the image requires you to understand. You may try to choose a star and imagine traveling toward it. At first it feels simple. It is right there, just beyond the glass, steady and bright. But then the mind begins to stretch. Even at the speed of light, the journey may take years. At the speeds available to human spacecraft, it would take vastly longer. The point is not near. It only appears near because the window has no way to show the gulf. This makes the darkness between stars more meaningful. It is not just the background of the view. It is the actual distance that the eye cannot measure. It is the space light crossed before it arrived. It is the absence of local reference points. It is the reason motion is hidden, the reason brightness deceives, the reason constellations flatten, the reason the universe can look calm while containing unimaginable separation. The darkness is not empty visual filler. It is the scale itself rendered invisible. As you look longer, you may begin to feel a strange double awareness. One part of you sees a simple field of lights. Another part knows that the field is not simple at all. The beauty of the scene lies partly in this split. The eye gives stillness and flatness. Knowledge gives depth and motion. Neither alone is complete. You do not merely look, you translate. You translate points into suns, brightness into uncertainty, darkness into distance, patterns into projection, stillness into hidden motion, and the present view into old light arriving from many pasts. The human eye begins the act, but it cannot finish it. The mind has to carry the view beyond what vision provides. That is why a person inside deep space might feel both close to the universe and separated from it. Close because nothing atmospheric stands between the eye and starlight. Separated because clarity is not the same as comprehension. The stars are sharp, but their distances remain hidden. The points are steady, but their lives remain invisible. The darkness is clean, but its depth is beyond sight. The hour now has a new character. The first minute removed the sky. The second stage sharpened the stars. The third revealed the stillness of a universe that is actually moving. And now the fourth stage has taken away the comfort of distance itself. You are no longer simply looking outward. You are realizing that outward is not a simple direction. It is layered beyond instinct, somewhere across the dark. If your chamber is placed far from glare and your eyes have settled into full night vision, you may begin to notice something softer than stars. Not a single point, not a moving object, a pale band, a faint ghostly river of unresolved light, stretching through the blackness, subtle enough that you might miss it if you expected spectacle, but immense enough that it is the galaxy you live inside, showing itself as a trace. At first it may not look like much. After the sharp points of stars, after the blackness without horizon, after the strange collapse of distance, your eyes may begin to notice something softer crossing the view. It is not a single star. It does not have the clean edge of a planet or the steady brightness of one bright sun. It is a faint band, pale and uneven, like a breath of light spread across the dark. This is the Milky Way, not the Milky Way as it appears in many photographs, full of glowing colors, bright dust lanes, purple clouds, blue star clusters, and golden light pouring across the sky. Not the dramatic river of fire we have learned from long exposure images and carefully processed telescope data. To your unaided eyes, even from deep space, it would be quieter than that. It would be a ghost of the galaxy. That ghostliness is not because the Milky Way is small or dim in reality. It is because you are inside it. You are not standing outside the galaxy, looking back at a grand spiral from a safe distance, the way illustrations often show it. You are embedded within one of its great structures, inside a disk of stars, gas dust, and dark matter, looking outward from a local neighborhood near one ordinary star. You cannot see the Milky Way whole because you are part of it. The mind wants a galaxy to be an object, something with a visible edge and a shape you can hold. But our galaxy is too large and we are too deeply inside it. From within, it does not appear as a complete spiral. It appears as a band because we are looking through the flattened disk where so many stars are gathered. Imagine standing inside a forest at night. You cannot see the forest as a shape from above. You cannot see its full boundary. What you see are trunks, shadows, openings, and the density of trees in certain directions. If you look along a thick part of the forest, the view becomes crowded. If you look toward a clearing, the darkness feels more open. You understand the forest not as a map, but as a presence around you. The Milky Way is something like that, but on a scale too large for the body to feel directly. When you look along the plane of the galaxy, your line of sight passes through many more stars than when you look above or below that plane. Their light, too faint and numerous to separate completely with the naked eye, blends into a soft glow. That glow is the pale river across the darkness. It is not a cloud in the atmosphere. It is not mist. It is unresolved starlight gathered across distance until the eye receives it as a luminous trace. In deep space without Earth's atmosphere and light pollution, that trace may be clearer than it is from many places on Earth, but it would still not become the full-color spectacle people often imagine. The human eye does not collect light the way a camera does during a long exposure. It does not wait for minutes or hours gathering faint photons and building them into a bright image. It lives in the present moment. It sees with cells that have biological limits. Under low light, the rods of the retina become important, and rods are sensitive to faint light, but they do not give rich color. So, the Milky Way may appear mostly pale, gray-white, silver, smoky, softly uneven. Some brighter knots may hint at star clouds. Some darker regions may appear like gaps or stains where interstellar dust blocks the light from more distant stars behind it. But these features would be subtle. They would ask you to slow down. They would not leap from the window like painted clouds. In the first minute, the Milky Way might be hard to notice. Your eyes are not fully adapted. Your mind is still adjusting to the absence of sky horizon and motion. But as the hour deepens, as your night vision improves, the faint band may become more present. It may seem less like an object and more like a direction in space where the darkness has thickened with hidden stars. The longer you look, the more it becomes clear that the band is not floating in front of the stars. It is made of stars. The pale river is not something separate from the points around it. It is the combined light of countless stars, too faint, too distant, or too crowded for your eye to isolate. The galaxy appears not by showing every part clearly, but by allowing many invisible details to merge into one soft presence. It is a reminder that seeing can be collective. One faint star may disappear into the limit of the eye. 1,000 faint stars may create a suggestion. Millions upon millions spread along a line of sight through the disk of the galaxy can become a band across the dark. You do not see them individually, but their combined light enters the chamber. The eye cannot resolve the crowd, so it receives a river. This is one of the most beautiful compromises in naked eye astronomy. The Milky Way does not reveal itself fully, but it does not vanish either. It gives just enough of itself to be felt. It tells you that you live inside something larger than the individual stars scattered across the window. It turns the star field from a collection of points into a home structure, though the home is far too vast to feel domestic. You are not outside looking in. You are inside looking through. That changes the emotional shape of the view. The stars without twinkle taught you that the universe is sharper without atmosphere. The stillness taught you that motion can be hidden by scale. The collapse of distance taught you that points of light flatten a three-dimensional reality. Now the Milky Way teaches that even the largest structure in your own cosmic neighborhood reaches your eyes as a faint, humble trace. The galaxy does not need to look grand in order to be grand. The human eye, small and limited, receives a pale band from a system containing hundreds of billions of stars. Somewhere within that disk are stellar nurseries, old star clusters, clouds of hydrogen, drifting dust planets, dead stars, and black holes. Somewhere within it are regions of violence and regions of quiet. But to you inside the chamber, much of that becomes only a soft, uneven glow. If your chamber were located somewhere far outside the plane of the galaxy, the view might change dramatically. If you were somehow lifted far above the Milky Way's disk, perhaps you could begin to see the galaxy as a great flattened structure, though still not as a bright photograph with the naked eye. If you were thrown into intergalactic space, the Milky Way itself might become an external object, a faint island of light against the dark. But in this journey, we remain within or near our galactic home. Here, the Milky Way appears as a band because we are inside the band. This inward position matters. It means the view is not only a view of distance, it is a view of belonging. Every star in the band is not equally close, and most are far beyond reach, but they are part of the same vast system that holds the sun. The chamber your body Earth far behind, and the pale river outside, all belong to one galactic environment. The galaxy is not scenery, it is location. The darker patches within the band may be especially haunting. To the eye, They might seem like empty breaks, places where the river of light thins or disappears. But many of these dark regions are not true holes. They are places where interstellar dust blocks or dims the starlight beyond. The darkness there has substance, though not substance your eyes can easily separate. So, even within the visible Milky Way, darkness does not always mean absence. Sometimes it means obstruction. A dark lane in the Milky Way is not necessarily a gap in the galaxy. It may be a foreground veil, a region where dust absorbs and scatters visible light. Behind it, the galaxy continues. Stars continue. Light continues, but not all of it reaches you in the form your eyes can receive. The pale river is therefore both revelation and concealment. It shows the galaxy by gathering unresolved starlight. It hides the galaxy behind dust distance and the limits of human vision. It gives a structure, but not the whole structure. It gives beauty, but not the full mechanics of that beauty. Outside the chamber, you may also search for other galaxies. A galaxy in the human imagination is often a bright spiral, wide and luminous, with sweeping arms and a glowing center. But to the naked eye, even the nearest large galaxy, Andromeda, appears only as a faint fuzzy patch under good conditions. In deep space, away from atmospheric interference and glare, it might be easier to notice, depending on where you are and how your chamber is oriented. But it would still not look like the rich spiral photographs seen in astronomy books. It would be a smudge of ancient light. That smudge contains hundreds of billions of stars. It is larger than it appears, far larger than the eye can easily grasp. Its light has crossed an immense distance before becoming a faint patch in your view. Yet without instruments, you would not see individual stars in it. You would not see spiral arms clearly. You would see only a small, soft presence, almost easy to miss. The grandest things are not always the brightest things to the eye. A nearby star can command attention. A distant galaxy can almost disappear. The mind knows Andromeda is enormous, but the eye receives it as a delicate blur. Again, seeing and knowing separate. The universe gives you a hint, and science gives the hint its scale. If your viewpoint allowed it, the Magellanic Clouds might appear as faint cloud-like patches, companion galaxies near the Milky Way. Like Andromeda, they would not show their full nature directly. They would appear soft, irregular, and pale, not as detailed systems full of stars, gas, and structure. Their names carry the old language of sky, clouds, but they are not clouds in Earth's air. They are galaxies. Before instruments revealed their nature, many deep sky objects were named by appearance. Clouds, nebulae, milky bands, fuzzy stars, pale patches. The names preserve the humility of first sight. They remind us that human beings first encountered the universe as appearances long before they understood the physical realities behind them. In deep space, you would return to that first sight. You would see hints before explanations. A pale band, a fuzzy patch, a dark lane, a faint cluster that comes and goes at the edge of vision. The scene would not overwhelm you with detail. It would ask for interpretation. The eye would give you enough to begin, then fall silent. That silence is not a failure of beauty. It is a different beauty. The beauty of direct vision in deep space may be austere, almost fragile. It does not have the saturated drama of processed images. It does not show the galaxy as a bright wheel. It does not reveal every nebula in red and blue. Instead, it gives the feeling of standing inside a nearly invisible architecture. The galaxy is around you, but only its faintest outlines arrive. This can make the pale river feel more intimate than a photograph. A photograph can show more. It can reveal structure, color, contrast, and hidden detail. But the naked eye view, limited as it is, has the quiet force of immediacy. These photons entered your eye in real time. They were not accumulated by a sensor over long exposure, not translated through software, not assigned color from wavelengths beyond sight. They are the simplest visual touch between your body and the galaxy. They are faint because the encounter is direct. As you continue looking, the Milky Way may seem to drift, not because it is moving visibly, but because your chamber's orientation changes or your attention shifts. If the chamber stays steady, the band remains crossing the window with patient subtlety. Its presence may become a kind of anchor, not like a horizon, but like a memory of structure. The universe is not merely a random spray of stars. You are looking through a disk. You are seeing where your galaxy is thickest along your line of sight. This changes the darkness above and below the band. Those regions may seem emptier, though they too contain stars and galaxies. The difference is perspective. Looking away from the galactic plane, your eye looks out through less of the Milky Way's dense disk and into a more open cosmic view. Looking along the plane, it looks through the crowded body of the galaxy itself. The view becomes geography, but not earthly geography. No mountains, no rivers, no oceans, no borders. Instead, density and direction. Dust and starlight, plane and halo, near stars and background glow. The map is not drawn on land, but in light. And still the human eye receives only the softest version of that map. This is why the Milky Way belongs at the center of the hour. It is the moment when deep space stops being only blackness and points. It becomes a place with structure, a place where you are located within something larger. The pale band gives the darkness an address. It says not in words that the chamber is not floating in an abstract void. It is inside a galaxy. That thought can be strangely calming. Even in the vastness there is belonging, not human belonging in the comforting sense. Not home as a house or a country or a planet under a blue atmosphere. But cosmic belonging. The atoms in your body were made through stellar processes. The sun is one star among the galaxy's many. Earth formed inside this larger system. The same pale river outside the window is not only scenery, but ancestry. Yet the Milky Way may give a sense of belonging, while also deepening the loneliness of sight. You are inside the galaxy and still cannot see it clearly. You belong to a structure too large to hold in one view. The band is both home and mystery, both evidence and veil. To see the Milky Way from deep space is not to see the galaxy solved. It is to see the limit of naked eye intimacy. The galaxy touches your vision, but does not surrender its full form. It gives a river because the eye cannot resolve the ocean. The hour now turns toward a new question. If the Milky Way is truly full of structure, dust stars and color, why does it appear so pale? Why do the images made by telescopes look so much more colorful, deeper, and more dramatic than this quiet view through the chamber window? The pale river has shown that the universe is larger than the individual stars. But it has also revealed something else. The eye does not see the universe as it is in full. It sees the universe through a narrow gate. And beyond that gate lies the hidden world of color wavelength exposure and translation. The pale river stays outside the window. For several minutes, imagine looking only at that one band. No diagram, no telescope, no processed image. Just the faint, uneven wash of the Milky Way crossing the dark. It is quiet, almost colorless, a silver trace in a field of black and white points. If you had never seen an astronomy photograph, you might not guess how much is hidden inside that pale shape. Then imagine the same region seen by instruments, not by better human eyes, but by machines that can wait longer than the eye, gather more light than the eye, and detect kinds of light the eye cannot feel at all. The pale band begins to separate into layers. Dust lanes thicken. Star clouds brighten. Young stars appear in clusters. Cold material glows in infrared. Hydrogen gas speaks in radio wavelengths. Energetic regions reveal themselves in ultraviolet or X-rays. What looked like a soft gray river becomes a complicated body of signals. The view through the window did not lie. It only spoke one language. Human vision is powerful, but it is narrow. It does not see all light. It sees only one small region of the electromagnetic spectrum, the band we call visible light. Beyond violet, there is ultraviolet. Beyond that, X-rays and gamma rays. Beyond red, there is infrared, then microwaves and radio waves. All of these are forms of light in the broader physical sense, but they do not become color in your mind because your eyes were not built to detect them. So much of deep space is real without being visible. Outside the chamber, radiation may be crossing the dark in wavelengths your eye cannot translate. Cold dust may shine softly in infrared. Hot gas may reveal itself in X-rays. Hydrogen clouds may stretch through the galaxy in radio light. Ancient radiation may fill space in microwaves. To an instrument designed for those wavelengths, darkness is not simply darkness. It has structure, temperature, motion, and history. But to your unaided eye, it remains mostly black. This does not mean your eye is weak. It means it is specialized. It belongs to a body evolved under the light of one star on the surface of one planet inside one atmosphere. It is tuned to the kind of light that helped living creatures find food, avoid danger, recognize faces, move through landscapes, and read the difference between day and night. It was shaped for survival, not for complete cosmic knowledge. The eye is a beautiful instrument, but not a universal one. Inside the retina, two main kinds of light-sensitive cells shape your view. Cones help you see color and fine detail in brighter conditions. Rods help you detect faint light in darkness, but they do not give rich color. When you look into deep space after your eyes have adapted, rods become crucial. They allow dim stars, the faint band of the Milky Way, and subtle patches of light to emerge. But rods trade color for sensitivity. That is why dim cosmic objects often look pale or gray to human vision. A nebula that photographs as red, blue, or green may appear nearly colorless through the eye, or may not appear at all without a telescope. A galaxy that contains billions of stars may reach you only as a gray smudge. The problem is not that the color is false. The problem is that too little light is entering your living eye at once for strong color perception to awaken. Color needs enough light to become color. This is one reason telescope images can feel so different from direct experience. A telescope gathers more light than the eye. A camera or detector can collect that light over time. It can remain patient for seconds, minutes, or even hours, letting faint signals accumulate. Your eye cannot do that in the same way. It is always living in the present, refreshing its view, tied to the biological rhythm of the nervous system. A camera can wait. Your eye must see now. Long exposure changes the universe, not by inventing objects, but by revealing faint ones. A dark region of sky that appears nearly empty to the naked eye may, under long exposure, fill with stars, galaxies, dust lanes, and delicate gas. The sensor catches photons that your eye would receive too sparsely to turn into a strong image. It adds patience where biology cannot. This is why many famous images of space feel brighter and more crowded than the view through a window in deep space. They are not simply photographs in the ordinary everyday sense. They are accumulated measurements. They are built from faint light gathered over time, corrected, combined, sharpened, stretched, and translated into forms human beings can understand. Some images represent visible light. Others include wavelengths no human eye could ever see directly. When you see a telescope image of a nebula in red, blue, gold, and green, you may assume it is showing exactly what your eyes would see if you were close enough. Sometimes the colors are close to what visible light cameras might record under certain conditions. Sometimes they are representative colors chosen to show different elements, temperatures, or wavelengths. Sometimes infrared light is mapped into visible colors, so the hidden structure can be seen by human eyes. That is not deception. It is translation. Think of a weather map. A map may show hotter regions in red and cooler regions in blue. The air itself is not painted that way. The color lets the human mind understand a pattern that would otherwise remain invisible or abstract. In a similar way, many space images use color to make data visible. They allow invisible wavelengths to enter human imagination. The image does not always show what the eye would see. It shows what the universe is doing. This distinction matters for the hour inside deep space. The view outside your chamber is direct but limited. The telescope image is processed but often richer in physical meaning. One is not simply true and the other false. They answer different questions. Your eyes ask what visible light reaches a human body right now. The telescope asks what signals are present, even beyond human sight, if we gather and translate them carefully. The universe is too large for only one kind of seeing. As you look out, a bright star may show a faint color. Perhaps one point feels bluish-white, another slightly orange. Those colors come from temperature, at least in a broad sense. Hotter stars can appear blue-white. Cooler stars can appear orange or red. But most of the faint stars remain nearly white to you because they do not deliver enough light for strong color perception. The eye simplifies the star field. A camera with enough exposure may separate subtle tones. A spectroscope can go further, splitting starlight into a pattern that reveals chemical elements, temperature, motion, and other properties. To your eye, a star is a point. To an instrument, that point can become a biography written in light. Every wavelength carries a different kind of message. Visible light gives one version of the cosmos. Infrared light reveals cooler objects and dust-shrouded regions where visible light may be blocked. Ultraviolet can reveal hot young stars. X-rays can show extremely energetic environments. Radio waves can map cold gas magnetic fields and structures that would never appear to the unaided eye. The dark outside the chamber is full of languages. Your eyes know only one of them. Now return to the pale Milky Way outside the window. It has not changed. It is still faint, still silver, still quieter than a photograph. But your imagination has changed the way it sits there. You can picture instruments widening the scene, not by making the galaxy more theatrical, but by allowing more of its reality to speak. In infrared, dust that looked like darkness may begin to glow. In radio, cold hydrogen may trace structures that no visible eye could follow. In X-rays, energetic regions may appear where ordinary sight sees nothing at all. The same patch of sky is many skies depending on the way you listen to light. The same pale band that looked like a faint river could become, through instruments, a layered structure of stars, dust, gas, radiation, and hidden nurseries where new stars are forming. One view is immediate. The other is interpretive. Both are real, but they are real in different ways. The danger is to think that the processed image is artificial, and the naked eye view is the whole truth. The naked eye view feels pure because it reaches you directly, but purity is not completeness. A narrow window can be pure and still narrow. The telescope image feels constructed because it passes through instruments and processing, but construction does not make it meaningless. Sometimes construction is what allows reality to appear. Human beings have always extended vision. A magnifying glass extends the eye into the tiny. A microscope reveals cells and microbes. A telescope reveals moons, rings nebulae, and galaxies. A radio telescope lets us observe light too long in wavelength for the eye. An infrared observatory peers through dust. An X-ray telescope watches high-energy regions the atmosphere would block from the ground. If you trust only your eyes, the universe is beautiful but sparse. If you add instruments, the same darkness becomes crowded with unseen structure. The chamber window gives you intimacy. The telescope gives you reach. The first lets you feel the silence. The second teaches you that the silence is not absence. This may change the way you look at the black between stars. At first it seemed empty. Then it became distance. Then the Milky Way showed that faint light can hide unresolved crowds of stars. Now the blackness becomes something else again, a region filled with signals your eyes do not receive. Infrared photons may be passing through it. Radio waves may be crossing it. High-energy radiation may be moving through it. Ancient microwave light may be present where the eye sees only dark. The darkness is not a blank page. It is a page written in ink your eyes cannot read. And yet there is a tenderness in the fact that you can read even a little of it. A handful of visible stars. The pale glow of the galaxy. A faint smudge of another galaxy if conditions allow. A subtle color in a bright star. These are not failures. They are the human share of the cosmos, the part that enters directly through the senses without machinery or translation. It is small, but it is ours. The problem begins only when we mistake that share for the whole. For much of human history, naked eye astronomy was the only astronomy. People watched the sun, moon, planets, stars, and Milky Way. They tracked seasons, built calendars, navigated oceans, told stories, marked rituals, and shaped civilizations under the visible sky. The eye was not useless. It was the first observatory. It gave humanity the first map of order beyond Earth. But modern astronomy has taught us that the visible sky is only the opening sentence. The rest of the book lies outside our natural sight. This does not make the opening sentence less beautiful. It makes it more mysterious. The fact that human eyes can see stars at all is already extraordinary. Light leaves a distant sun, crosses years of emptiness, enters a small chamber, passes through a clear window, passes through the lens of your eye, and becomes a signal in the nervous system. A physical event far away becomes experience. But the same experience also reveals its boundary. You cannot see the infrared glow of cold dust. You cannot see ultraviolet radiation from hot stars. You cannot see the radio whisper of hydrogen spread through the galaxy. You cannot see the microwave afterglow from the early universe. You cannot see the magnetic fields shaping charged particles. You cannot see dark matter at all through light, though its gravity helps shape galaxies. The visible view is not the universe. It is one translation made by biology. As the hour moves on, this knowledge may make the scene outside feel deeper rather than poorer. The fact that the window remains dark no longer means that nothing is there. It means you are surrounded by realities passing through the scene without becoming image. The blackness becomes layered. Every empty region may contain wavelengths, particles, fields, and histories that require another kind of seeing. At first, the lack of color may feel like disappointment. The universe was supposed to be more vivid. The nebulae were supposed to shine. The galaxy was supposed to glow like a cosmic river. But now the disappointment begins to soften. The missing color is not a sign that the universe is dull. It is a sign that your senses are small compared with what exists. The awe moves from the image to the limitation. The chamber remains quiet. The stars remain steady. The Milky Way remains pale. Nothing suddenly blooms into false spectacle. But now the restraint itself has meaning. You are looking at the narrow visible edge of something much larger. Beyond the colors your eyes can see, the universe continues. It glows in infrared behind dust. It flashes in X-rays near extreme objects. It murmurs in radio wavelengths. It carries old microwave light from the early cosmos. It moves through forms your eyes cannot turn into blue, red gold, or violet. And once that idea settles, the next question begins. If so much light can pass unseen, what else might touch you without appearing? If deep space contains invisible wavelengths, could it also contain invisible particles, radiation, and traces of energy that do not simply cross the window, but pass through the chamber, through the body, even through the eye itself? The hour has moved from what you see to what you cannot see. Now it must move one step closer into the darkness that touches you. By now, the darkness outside the chamber no longer feels simple. At first, it looked like absence. Then it became the place where stars held steady, where motion hid behind scale, where distance collapsed into points, where the Milky Way appeared as a pale river, and where colors beyond the eye remained unseen. The blackness has changed each time you have looked at it more carefully. Now it changes again, because deep space is not only something you look into. In a very real sense, it is something that can reach you. The chamber protects your body from the vacuum. It keeps pressure around your lungs, warmth around your skin, and breathable air within reach. It shields you from the most dangerous parts of the environment outside. But the larger truth remains. Space is not an empty stage with stars placed on it. It is crossed by particles, radiation, magnetic fields, dust, and light in forms your senses cannot easily recognize. The eye sees blackness. Physics sees traffic. This traffic is not like traffic on a road. Most of deep space is still unimaginably sparse compared with air-water stone or any ordinary material on Earth. But sparse does not mean nothing. A region can be almost empty by human standards and still contain enough particles, radiation, and invisible activity to matter. Empty is not always empty. Between the stars, there is gas thinner than any vacuum most people can imagine. There are particles drifting across enormous distances. There is dust, not like dust on a shelf, but tiny grains spread through space, sometimes so thinly that miles and miles might contain almost nothing. And yet, over light years, these grains can dim and redden starlight. And there are cosmic rays. The name can be misleading because many cosmic rays are not rays in the ordinary sense of light beams. They are high-energy particles, often atomic nuclei or protons, moving through space at tremendous speeds. Some come from the sun. Some come from more distant and more violent places, such as supernova remnants or other energetic cosmic environments. By the time they arrive near a spacecraft, they may seem invisible and silent, but they carry enough energy to interact with matter, including living tissue. This is not something to make theatrical or terrifying. In our imagined journey, the chamber is safe enough for observation. The point is not to turn the hour into a disaster. The point is more subtle. Even when the view seems still, the body is not separated from the universe as completely as the eye might imagine. Invisible particles can cross the dark without appearing as stars, colors, clouds, or shadows. Some may pass through shielding, some may pass through the body, some may even create something like a visual experience. Astronauts have reported seeing brief flashes of light when their eyes were closed, or when they were in darkness, especially during missions beyond the protective environment of Earth. These flashes are thought to be caused by high-energy particles interacting with the eye, the retina, or nearby parts of the visual system. They do not come from a star shining through the window. They are not ordinary light entering from outside. They are the darkness touching vision from within. Imagine sitting in the chamber after your eyes have adapted. The stars are steady. The Milky Way lies pale across the black. You are no longer expecting a dramatic rush of motion. Then for an instant, something appears. A tiny streak, a dot, a brief spark. It is gone before you can study it. It may not seem to belong to the window. It may feel as if it happened somewhere inside the eye itself. You might look again, and find only the same steady star field. No object crossed the glass. No visible flash came from the dark. The event was private, almost interior, but its cause may have come from space. That small flash would be stranger than a bright star. A star sends visible light across distance and into your eye. The process is ancient, but familiar enough. A photon enters the retina, responds, the brain builds an image. But a cosmic ray flash suggests a different kind of contact. A particle, not part of the visible scene, interacts with the visual system and creates the sensation of light without arriving as ordinary light. The universe has entered the act of seeing by another door. This is one of the most powerful details in the entire hour because it quietly breaks the boundary between observer and environment. Until now, you have looked outward. You have asked what the window shows, what the eye can gather, what remains hidden beyond visible wavelengths. But now, deep space is not only outside the glass. Its particles become part of the experience of perception itself. The view is no longer purely visual. It is physical. On Earth, the atmosphere and magnetic field protect us from much of this radiation environment. They do not block everything, but they change what reaches the surface. High-energy particles interact with the atmosphere above us, creating cascades of secondary particles. The sky that gives us blue light and weather also acts as part of a shield. Earth is not just beautiful because it has air. It is habitable because that air, along with the planet's magnetic environment, softens space before space reaches the ground. In deep space, that protection is no longer naturally around you. The chamber must replace some of what Earth once did for free. Its walls, shielding materials, and systems become the artificial boundary between a human body and an environment where particles move without air, where sunlight can be harsh, where radiation can come from the sun or from far beyond it. The quiet view outside hides this practical truth. Space may look empty, but survival depends on respecting what the eye cannot see. Again, sight is not enough. A person looking through the window might feel calm because the stars are steady and the darkness is silent. But instruments would tell a more complex story. They could measure charged particles, radiation levels, solar activity, and energetic events invisible to the eye. They could warn of danger that would not appear as a glowing cloud or a visible wave. During a quiet period, the radiation environment may be relatively stable. During a solar storm, particles from the sun can become far more intense. If the chamber is within the wider influence of the sun space, weather matters. Solar flares and coronal mass ejections can send charged particles into space, and those particles can affect spacecraft electronics, astronauts, and the invisible environment through which the chamber moves. The sun may be far away in the view, perhaps only a brilliant point, or a direction avoided to protect the eye. But its influence extends far beyond its visible disk. This is another way deep space refuses to match appearance. A region may look like darkness and still lie within the reach of a star's wind. The solar wind, A stream of charged particles, flowing outward from the sun, fills the heliosphere, the vast bubble of solar influence surrounding the solar system. Far beyond Earth, far beyond the familiar warmth of daylight, particles from the sun continue moving through space. The eye sees no wind, but the wind is there. Not wind like air moving through trees, not a breeze against the skin, not the pressure of weather crossing a field. It is a plasma, a flow of charged particles. It carries magnetic fields. It interacts with planets, comets, and interstellar material. It helps shape the invisible boundary between the sun's domain and the surrounding galaxy. In the chamber, you would not hear it. You would not feel it as air. Yet instruments could detect it. Beyond the solar wind, beyond the sun's strongest influence, the interstellar medium begins to matter more. This is the thin material between stars. Gas dust, magnetic fields, cosmic rays, and radiation spread across the galaxy. It is not dense like a fog. If you could stretch out your hand, you would not feel it. But across enormous distances, it shapes what astronomers observe. It absorbs light. It emits light. It forms clouds where stars may eventually be born. The space between stars is not a perfect void. It is a nearly empty environment with history. Some of its atoms may have been blown out by dying stars. Some dust grains may contain elements forged in earlier generations of stellar life. Some regions may be enriched by supernova explosions. The thinness itself can be misleading, because a handful of atoms in each cubic centimeter may sound like almost nothing, but over light years, that material becomes a galactic presence. It can hide stars. It can form stars. It can carry the memory of stars that died long before the chamber existed. If your eyes could see the interstellar medium directly in all its forms, the blackness outside might no longer look black. It might appear layered with faint gas, charged flows, magnetic structures, and radiation. But your eyes cannot. The material is too thin, too faint, too spread out, or glowing in wavelengths outside your visible range. The chamber drifts through a universe that is physically present but visually withheld. Because the cosmic ray flash, if it comes, is not only a phenomenon to describe, it is a reminder that the body is made of matter, and matter is not sealed away from the cosmos. The particles outside are not mythical. They are physical. They interact with detectors, spacecraft shielding, and sometimes biological tissue. Your eye is part of the universe. It tries to observe. There is no absolute separation between the viewer and the view. On Earth, that is also true, but it is easier to forget. The atmosphere surrounds us so completely that it becomes invisible in daily life. Sunlight enters the skin and eye. Cosmic particles reach the ground in altered forms. The body carries atoms made in stars. But because the world is familiar, the connections feel ordinary. Deep space strips away familiarity and makes the connection more exposed. A tiny flash in darkness can become a lesson in belonging. Not warm belonging, perhaps, not comforting belonging, but physical belonging. The same universe that sends visible starlight also sends invisible particles. The same deep space that looks empty contains conditions that can touch instruments and bodies. The same darkness that seemed far away is not completely far away after all. Some of it arrives. This does not mean deep space is crowded in a human sense. The chamber is not moving through a thick storm of visible matter. You are not surrounded by glowing sparks. You are not in a shining dust cloud. Most of the time, the view remains quiet, and the radiation environment remains something instruments understand better than eyes do. The drama is not in spectacle, it is in invisibility. Some realities are detected by instruments. Some are inferred through effects. Some pass through almost unnoticed. The body, like the eye, is not a perfect boundary. You may look again at the pale band of the Milky Way and imagine all the invisible movement woven through it. Cosmic rays from ancient explosions, dust from old stars, gas drifting between stellar neighborhoods, particles from the sun radiation crossing the galaxy, magnetic fields shaping flows too subtle to see. The band remains pale, the points remain steady, the window remains dark. But the meaning of the view has thickened. It is no longer a picture. It is an environment. A picture is something you observe from outside. An environment is something you are inside. Deep space, even seen through protective glass, is not merely an image placed before you. It surrounds the chamber. It carries signals through and around it. It makes demands on the materials that protect you. It quietly reminds you that human life depends on a fragile border. Inside breath, outside particles, inside warmth, outside radiation distance, and thinness beyond ordinary imagination. The contrast could become frightening, but the tone of the hour remains calm, because calm is also truthful. Space does not need to become loud to be serious. It does not need to threaten dramatically in order to be powerful. Its reality is more patient than that. It simply exists according to conditions the human body did not evolve to endure without help. The chamber is your temporary atmosphere. The window is your temporary sky. Beyond it, the universe continues without needing either. As the hour nears its final stage, there is still one more hidden presence. It is not a cosmic ray. It is not solar wind. It is not dust between stars. It is not a faint galaxy or a dark lane in the Milky Way. It is older than all the stars you see through the window, older than the galaxy, as it now appears, older than Earth, older than the sun, older than any human eye. It fills the universe in every direction, but your eyes cannot see it. If instruments could translate it, the blackness outside the chamber would no longer be only black. It would carry the faint afterglow of the early universe itself, stretched by cosmic expansion into microwave light. You would be sitting inside darkness that is not merely dark, surrounded by ancient light, too cold and too long in wavelength to enter your vision. The hour has taken you from the visible to the invisible. Now it moves toward the oldest invisible light of all. The final stage of the hour begins in a darkness that no longer feels empty. By now, you have learned to hesitate before calling it nothing. The dark outside the chamber has already hidden distance, motion, faint color, dust particles, and radiation. It has held steady stars, a pale galaxy, soft smudges of other galaxies, and invisible traffic moving silently through space. Each time the view seemed simple, it became deeper. Now the deepest hidden presence is not a star, not a galaxy, not a particle from the sun, and not a cosmic ray crossing the eye. It is light, ancient light, light, so old, so stretched, and so cooled by the expansion of the universe that your eyes cannot receive it as light at all. It does not arrive as blue, red gold, or silver. It does not appear as a glow around the chamber. It does not brighten the black between stars. To human vision, it remains completely invisible, and yet it is everywhere. This is the cosmic microwave background, the faint afterglow of the early universe. It is not a spotlight, not a beam, not a star, not a distant object sitting in one direction. It is observed from every direction because it belongs to the early universe itself, a relic from a time long before the sun, before Earth, before the Milky Way had its present form, before any eye existed to look outward and ask what darkness meant. If your eyes could see microwave light, the blackness outside would no longer look the same. But human eyes cannot. So you sit inside the chamber, looking into what appears to be ordinary deep space, Stars, darkness, perhaps the pale band of the Milky Way. The oldest light available to observation is present as part of the background of the universe, but it does not enter your mind as image. It crosses the scene without becoming visible. It is one of the strangest examples of the central lesson of the our reality is not limited to what human sight can hold. The cosmic microwave background comes from when the universe was much younger, hotter, and denser than it is now. For a long early period, light could not travel freely in the way we imagine starlight traveling today. The universe was filled with charged particles, and photons were constantly scattered. Space itself was not transparent. Then, as the universe expanded and cooled, conditions changed. Electrons and atomic nuclei could combine into neutral atoms, and light could finally move more freely through space. That released light has been traveling ever since. But the universe did not stand still while it traveled. Space expanded. The wavelengths of that ancient light stretched with the expansion. What began as much hotter radiation became cooler and longer in wavelength. By the time it reaches the present universe, it is not visible light. It is microwave radiation, cold and faint, filling the sky in every direction. To your eyes, it is darkness. To instruments, it is one of the most important signals in cosmology. This is a quiet reversal of nearly everything the hour first seemed to promise. You began by asking what you would see. The final answer is that one of the most profound things around you cannot be seen at all. The eye meets blackness, but the blackness contains a trace of the universe when it first became transparent to light. This ancient radiation is not dramatic in the visual sense. It would not look like a nebula. It would not curl like smoke or glow like fire. Even when scientists map it, they must translate tiny differences into visible colors that human beings can interpret. Those colors are not what your eyes would see from the chamber. They are a scientific language, a way of making minute variations in temperature and structure understandable. Again, color becomes translation. Without that translation, the ancient light remains hidden. There is something almost peaceful in this. The oldest light does not announce itself with spectacle. It does not overpower the stars. It does not make the chamber glow. It is present as a background, faint beyond ordinary human feeling, carrying information from a time so early that imagination must move slowly to approach it. The stars outside the window may already have felt ancient. Some of their light began traveling years, centuries, or thousands of years ago. A faint galaxy may have sent its light across millions of years. But the cosmic microwave background reaches back much farther than any visible star in your direct view. It is not light from a star at all. It is light from the early condition of the universe itself. It is older than starlight. That thought changes the blackness one final time. The darkness between the stars is not only the absence of visible light, it is also the place through which invisible ancient radiation is present everywhere quietly, without becoming part of naked eye experience. It surrounds your chamber from all sides, not because it comes from one wall of space, but because looking far enough in any direction means looking back toward that early, glowing universe. The farther astronomy looks, the deeper it looks into time. This is not just a metaphor. Light takes time to travel. To look far away is to see the past. When we observe distant galaxies, we see them as they were when their light began the journey. When we study the cosmic microwave background, we are reading one of the oldest light signals available to us, a boundary beyond which ordinary light from earlier times cannot easily show us a clearer picture. Your eyes cannot see that boundary. But the boundary is there in the evidence. This is one of the reasons deep space is more profound than it is visually dramatic. The view does not tell the whole story at once. The black between stars does not come with labels. It does not say, here is distance, here is time, here is radiation from the early universe, here are invisible wavelengths, here are particles, here is dust, here are fields. The human eye receives a simplified scene, then science has to unfold it. The eye gives the surface, science gives the depth, and yet the eye is still where the wonder begins. Without the first sight of stars, without the first feeling of darkness, without the pale river of the Milky Way, the invisible universe might feel too abstract. The direct view anchors the mind. It gives the listener a window, a body, a moment, a place to begin. Then the invisible layers can slowly gather behind it. The chamber itself remains almost unchanged. Nothing outside suddenly brightens. No ancient glow emerges from the black. No cosmic wall appears at the edge of vision. The same stars sit in the same darkness. The Milky Way, if visible, still looks pale and soft. A faint galaxy may remain a smudge. The view is outwardly quiet, but inwardly the scene has widened. You now know that the dark between those points is not merely blank. You know that some of the light around you is too stretched for your eyes. You know that the most ancient observable radiation in the universe does not look ancient because it does not look like anything at all. It must be measured, mapped, translated, and understood through instruments that extend human sight into a range the body cannot enter. This makes the final minutes of the hour feel different from the first. At the beginning, the darkness may have felt like a loss. The loss of the sky, the loss of color, the loss of familiar motion, the loss of horizon and sound. Now the same darkness has become a container of unseen history. It is not warmer, it is not safer, it is not more human, but it is deeper. You may look at a dark patch between stars and imagine nothing there. Then you remember that the eye is not the judge of all presence. In that darkness, microwave radiation from the early universe is part of the background of reality. Infrared light from cold dust may be crossing unseen. Radio waves may pass without color. Cosmic rays may move through the chamber's surroundings without becoming image. The universe is not absent because the eye does not receive it. This is not a lesson the body learns easily. Human beings are visual creatures. We trust sight deeply. We say, I saw it with my own eyes, as if that settles reality. On Earth, this trust is often useful. Sight guides the hand, the step, the face, the path, the danger, the shelter. But in deep space, sight becomes humble. It still matters, but it cannot rule alone. The universe is larger than the senses that discovered it. This does not make human perception meaningless. It makes it touching. A fragile eye shaped by Earth can still receive light from stars. A mind born under one atmosphere can still understand that the atmosphere was only a local veil. A species that evolved for daylight and survival can build instruments to hear microwaves from the early universe. The limitation is real, but so is the reach beyond it. That reach is one of the quiet triumphs of science. Science does not replace wonder. It makes wonder more patient. It teaches us not to stop at the first appearance, not to mistake darkness for emptiness, not to confuse faintness with smallness, not to assume that what the eye misses does not exist. It gives us ways to ask, what else is present? What else is moving? What else is glowing? What else has been stretched beyond the colors we know? Inside the chamber, the hour is nearly over. Nothing outside has changed dramatically. The stars have not rushed past. The Milky Way has not become a glowing river of painted color. The ancient light has not revealed itself to your eyes. The cosmic rays, if they touched your vision at all, did so briefly, almost privately. The blackness remains black. But you are not looking at the same darkness anymore. At the beginning it was absence. Now it is depth. At the beginning it was a void where the sky had disappeared. Now it is a layered universe containing visible light, invisible radiation, hidden motion, ancient signals and distances that vision alone cannot unfold. The hour did not make space visually louder. It made your understanding quieter and wider. This is a different kind of ending. Not a final image, but a changed way of seeing. You may look once more toward the stars. They are still steady. Some shine with faint color. Most remain pale. The space between them appears black. Somewhere within that blackness, microwave light older than galaxies crosses the chamber's surroundings without touching your eye, as image. It has been traveling since the early universe became transparent, stretched by expansion into a form your body cannot recognize. It is there. You cannot see it. Both statements are true. That is the final humility deep space gives to the human eye. It allows you to see enough to be moved, but not enough to be complete. It reminds you that direct experience is real, yet partial. It shows that the universe can be present without being visible, active without appearing busy, ancient without looking old, full without looking crowded. The 1-hour journey ends with that quiet paradox. If you were inside deep space for 1 hour, you might not see the spectacular universe you expected. You might see blackness, steady stars, a faint galaxy band, perhaps a few soft patches, perhaps nothing more dramatic than a tiny flash inside the eye. But behind that restraint would be a reality far larger than the scene itself. Stars in motion, distances beyond instinct, colors beyond vision, particles crossing darkness, an ancient light filling the universe unseen. So the real answer is not simply that deep space would look dark. It would look dark because your eyes are human. And once you understand that, the darkness becomes one of the most meaningful sights in the universe. After 1 hour in deep space, the most surprising thing may not be what appeared, but what did not. The universe did not unfold like a painted nebula across the window. It did not rush with visible speed or fill the darkness with constant motion. It offered something quieter, sharp stars, black distance, faint traces of the galaxy, and the unsettling sense that the eye was receiving only a small surface of reality. But that quietness is not emptiness. It is a lesson in scale and limitation. Human vision was shaped for daylight, firelight, forests, faces, water danger, and the familiar distances of Earth. It was not built to measure light years, see microwave afterglows, read infrared clouds, or feel the invisible particles passing through the dark. And still, from this narrow doorway, we have learned to ask larger questions. We have built instruments that extend the eye images, that translate invisible wavelengths, and theories that reveal motion where the view seems still. Deep space may look almost silent to us, but science has taught us that silence can be full of structure, memory, and ancient light. So, perhaps the real wonder is not that space looks less colorful than we imagined. It is that the darkness once understood becomes deeper than color. It reminds us that the universe does not need to match human expectation in order to be beautiful. Sometimes its greatest truth is found not in spectacle, but in the quiet realization that we are looking out from a small island of vision into a reality far larger than sight itself.